Today, we are mastering the differentiation of products and quotients, a core component of the Cambridge 979 Pure Mathematics syllabus. Our objectives are threefold. First, to apply the product rule for functions multiplied together. Second, to apply the quotient rule for functions divided by one another. And finally, to combine these with the chain rule for more complex expressions. In your A-level examinations, specifically Paper 1 and Paper 3, you will frequently encounter complex expressions involving algebraic, exponential, and logarithmic terms. You cannot differentiate these by simply differentiating the parts individually. You must use specific rules to find the gradient function. Mastering these is essential for securing high marks in calculus questions. The product rule is used when a function y is the product of two simpler functions of x, which we call u and v. The formula states that if y equals u times v, then the derivative, dy by dx, is equal to u times the derivative of v with respect to x, plus v times the derivative of u with respect to x. Mathematically, the derivative of a product is not simply the product of the derivatives. Instead, it is the first function multiplied by the derivative of the second, plus the second function multiplied by the derivative of the first. This accounts for how both parts of the product change simultaneously relative to x. Consider a rectangle with sides u and v. Its area is the product u times v. When x changes, u increases by a small amount du, and v increases by dv. The change in area consists of u times dv and v times du. The tiny corner du times dv is negligible. Let's apply the product rule to the function y equals x squared natural log of x. First, we identify our two functions. Next, we find their individual derivatives with respect to x. Now, we substitute these into the product rule formula, u times dv dx plus v times du dx. Simplifying the first term, x squared divided by x gives us x. Finally, we factor out the common term, x, to provide a clean, exam-ready answer. Looking at the graph, at the point 1, 0, the gradient is exactly 1. This matches our formula. 1 times the quantity 1 plus 2 times natural log of 1, which is 1. Concept: the quotient rule is essential when your function y is the result of one function u divided by another function v. The formula states that if y equals u over v, then the derivative dy by dx is v times the derivative of u minus u times the derivative of v, all divided by v squared. A vital reasoning point here: the order in the numerator matters because of the subtraction. We always start with the denominator, v, multiplied by the derivative of the numerator. A helpful mnemonic used by many top students is low d high minus high d low, all over low squared. This ensures you don't swap the terms and get the sign wrong, which is a common pitfall in the 9709 exams. Let us differentiate the quotient y equals 2x minus 4, divided by 3x plus 2. First, identify the numerator as u and the denominator as v. Find the derivatives of both. Now, apply the quotient rule. Remember, v times du dx minus u times dv dx, all over v squared. Expand the brackets in the numerator carefully. Subtracting the terms, 6x minus 6x cancels out, and 4 minus negative 12 becomes 4 plus 12. Notice we leave the denominator in its squared form. In Cambridge exams, it is rarely necessary to expand the denominator, and leaving it as a square is actually preferred as it makes finding stationary points much easier later on. In more advanced 9,709 questions, your u or v terms may themselves be composite functions. This requires the chain rule to be nested within your product or quotient rule calculation. Let's differentiate y equals x times e to the power of 1 minus x squared. Here, u is x and v is e to the power of 1 minus x squared. U equals x, so du dx equals 1. To find dv/dx, we use the chain rule. The derivative of e to the power of f of x is e to the power of f of x times the derivative of the exponent. So dv/dx equals e to the power of 1 minus x squared times negative 2x, which is negative 2 by e to the power of 1 minus x squared. Now apply the product rule. U times dv/dx plus v times du/dx. This simplifies to negative 2x squared e to the power of 1 minus x squared plus e to the power of 1 minus x squared. Factoring out the exponential term gives the final derivative, e to the power of 1 minus x squared times 1 minus 2x squared. This derivative allows us to find the exact coordinates of the stationary points. By setting the gradient to 0, we find x equals plus or minus 1 over the square root of 2, as seen on the graph. Let us solve a typical Cambridge 9709 question. The curve has equation y equals natural log of x divided by x squared. Find the exact coordinates of the stationary point. To find stationary points, we must first find the gradient function and set it to 0. Since this is a fraction, we use the quotient rule. Let u equal natural log of x and v equal x squared. Then du/dx is 1 over x and dv/dx is 2x. Now, apply the rule v du/dx minus u dv/dx all over v squared. Simplify the numerator. X squared times 1 over x is simply x. Factorize an x out of the numerator to simplify the fraction. For a stationary point, set dy/dx equal to 0. This gives natural log of x equals 1/2. Using the definition of logarithms, x equals e to the power of 1/2, which is the square root of e. Finally, find the y-coordinate by substituting x back into the original equation. The exact coordinates are the square root of e and 1 over 2e. In Cambridge examinations, small errors in calculus can lead to a significant loss of marks. Here are the most common pitfalls to avoid. The most frequent error is reversing the numerator, writing u dv/dx minus v du/dx instead of v du/dx minus u dv/dx. This leads to a sign error in your final gradient. Always start with the denominator term. When differentiating a product like x sine of 2x, many students forget to differentiate the inside of the function. They write the derivative of sine of 2x as cosine of 2x instead of 2 cosine of 2x. In the quotient rule, students often forget to square the denominator, or they mistakenly differentiate the denominator in the bottom of the fraction. The formula is always v squared. Many marks are lost not in the calculus, but in the subsequent algebra. Be extremely careful when distributing negative signs across brackets in the quotient rule numerator. If the question asks for an exact coordinate, do not use your calculator to provide a decimal like 0.5. Leave your answer in terms of e, pi, or fractions. To maximize your marks in the Pure Mathematics 3 paper, keep these examiner insights in mind. Examiners look for the explicit application of the rule. Even if you make a calculation error later, you can often secure method marks by clearly stating your choice for u and v and showing the unsimplified substitution into the formula. Before you start, ask yourself, is this a product or a quotient? A common trick in 9709 is presenting a function like x squared times e to the power of negative x. While you could use the quotient rule by rewriting it, it is usually faster and less prone to error to use the product rule directly. Typically, a differentiation question is worth 3 to 5 marks. Usually, 1 mark is for correctly identifying and differentiating u and v, 1 or 2 marks for the correct application of the rule, and the final marks for simplification or finding a specific value. When differentiating functions involving e, remember that e to the power of x is its own derivative. This often allows for easy factorization in the final step. Always look to factor out exponential terms. It is a hallmark of an A-star student's work. It is time to test your understanding. Please pause the video and attempt these 3 questions before we move on to the solutions. The easy question involves a standard product of a polynomial and an exponential. The medium question requires a steady application of the quotient rule. The hard question asks for a specific gradient value, requiring both the quotient rule and substitution. Pause the video now. Let us go through the solutions to see if your reasoning matches the exam requirements. For the first question, we use the product rule to differentiate x cubed times e to the x. We let u be x cubed and v be e to the x. Then, the derivative of u is 3x squared, and the derivative of v is e to the x. Applying the formula, u times dv dx plus v times du dx gives us this expression. Factoring out the common terms x squared and e to the x gives x squared e to the x times x plus 3. Next, for the medium difficulty question, we use the quotient rule. Here, u is 5x plus 1, and v is 2x minus 3. The derivative of the numerator is 5, and the derivative of the denominator is 2. The quotient rule states v times du dx minus u times dv dx, all over v squared. Expanding the numerator, we get 10x minus 15 minus the quantity 10x plus 2. The 10x terms cancel out, leaving us with negative 17 over the square of 2x minus 3. Finally, we have the gradient question. We need the derivative of natural log of x over x plus 1 at the point where x equals 1. Identifying u as natural log of x and v as x plus 1. The derivatives are 1 over x and 1 respectively. Applying the quotient rule gives us this general expression for the derivative. Now, substitute x equals 1 directly into this expression. Since the natural log of 1 is 0, the numerator simplifies to 2 minus 0. The gradient at x equals 1 is 1/2. To conclude, here are the essential points for your revision. Use the product rule when functions are multiplied. dy by dx equals u dv dx plus v du dx. Order doesn't change the result, but consistency helps prevent errors. Use the quotient rule for fractions. dy by dx equals v du dx minus u dv dx, all over v squared. Remember that starting with the denominator, v is non-negotiable due to the subtraction in the numerator. In Cambridge 9709 exams, the derivative is often just the first step. Factoring your answer, especially when exponential terms are involved, makes subsequent steps like finding stationary points much more manageable. Always check if your u or v terms require the chain rule. Missing a small internal derivative is the difference between an A and a B grade. Clearly define your u, v, and their derivatives. This structure not only guides you through complex problems, but also ensures you capture maximum method marks from the examiner.